students, today's lesson is on algebraic expressions. So to start with, let's get some definitions. For like terms are terms that have the same variables raised to the same exponents. So for example, 2x and 1/2 x. Those would be like terms because they both have x and neither one of them is squared or taken to a cubed root. They're both just terms of x. Same thing, another example of a pair of like terms would be 3y squared and 2y squared, or let's say negative 2y squared. Those are both like terms as well. They're both terms that have y squared, okay? And then simplest form is an expression. An expression is in simplest form when there are no more like terms and no parentheses. So when you have simplified it as far as you can. A few more definitions. Coefficient is the number in front of a variable. So for example, in the term 2x, 2 is the coefficient. In the term negative 1/2 y squared, negative 1/2 is the coefficient. It's whatever number is in front of the variable. And then a constant is a number in an expression without a variable. So if you have an expression like 2x plus 5, here's the constant right here is the 5. 2 is the coefficient, 5 is the constant. Okay? So let's go ahead and look at some examples. First, we're going to identify terms and like terms. So let's identify the terms here. Our first step, always in identifying terms, is to rewrite the expression as a sum of terms. We don't want any subtraction symbols. We want to change it to all addition. So it's a sum of terms. So I'll rewrite this to 9x plus negative 2 plus 7 plus negative x. Okay, so now we're going to go ahead and write the terms. We have 4 terms, 9x, negative 2, 7, and negative x. So that's our list of terms. We have 4 of them. 9x, negative 2, 7, negative x. I'm going to list them with commas in between just to make it a list. And then we're also going to identify the like terms. So here are the terms that are like each other. 9x and negative x are like terms. Those are both terms that have x raised to the first power or just by itself. And then we have negative 2 and 7. Those are both constants. Those are like terms because there is no variable involved with either of them. All right, let's look at the second example. Z squared plus 5z minus 3z squared plus z. So our first step is to write this as a sum of terms. So we don't want any subtraction. We just want to have addition. Z squared plus 5z plus negative 3z squared plus z. Again, we have 4 terms. I'm going to go ahead and list them. Z squared is a term. 5z is a term. Negative 3z squared is a term. And z is a term. Okay, now we're going to look for our like terms. We have 2 terms that have z squared as part of the term. Those are like terms. And then we have 2 terms that have z. So those 2 are like terms. So go ahead and list these together. 5z and z are like terms. Z squared and negative 3z squared are like terms. Let's look at our next example. We're going to simplify an algebraic expression. So I'm going to start again by writing this as a sum of terms. I have 3/4 y plus 12, and instead of subtraction, I'm going to change this to adding the opposite, so negative 1/2 y. And instead of minus 6, plus negative 6. All right, now I'm going to group this so that I have my like terms together so I can easily see what needs to be added together. So I'm going to rewrite this as 3/4 y, and then here's a like term, plus negative 1/2 y, plus, I'll put my two constants together, 12 plus negative 6. Now I'm going to go ahead and combine my like terms. So 3/4 y plus negative 1/2 y would be positive 1/4 y. And 12 plus negative 6 is 6. So 1/4 y plus 6. Here's another expression to simplify. Notice that I have this negative 1/2 outside of the expression 6n plus 4. I need to distribute that negative 1/2 to both the 6n and the 4. So before I can even write this as a sum of terms, I need to distribute my negative 1/2. Negative 1/2 times 6n is negative 3n, plus negative 1/2 times 4 is negative 2, plus 2n. Look at that, it's already a sum of terms for us, so I'm going to go ahead and just rewrite with the like terms grouped together. Negative 3n plus 2n plus negative 2. Now I have negative 3n plus 2n is negative n plus negative 2. And then in simplest form, I am going to go ahead and put this back to subtraction now. So I say negative n minus 2. That's simplest form. Negative n minus 2. Okay. So let's look at this application. We have these prices. Drinks, small, medium, and large, and popcorn, $3 and $4. Let me scroll down here. Okay, so each person in a group buys a ticket, a medium drink, and a large popcorn. We want to write an expression in simplest form that represents the amount of money the group spends at the movies and interpret the expression. Okay, so I'm going to have a variable in here. The thing that I don't know is how many people I have. So we'll call the number of people X. Okay, and then each person buys a ticket. So tickets are $7.50, so that's $7.50 times however many people. Plus, each person buys a medium drink, that's $2.75 times however many people are going. Plus the large popcorn, which is $4. So $4 times however many people are going, 4x. These are all like terms. These are all terms with x. So I can go ahead and simplify. Let's see here. $7.50 plus $2.75. $7.50 plus $2.50 would be $10. So this is $10.25 times x. Plus my popcorn, that's 4x. Then I have $10.25 plus 4, that's $14.25 times x, the number of people that go. So interpret the expression that's telling us that every person that goes is going to spend $14.25. So if we want to know the total cost, we would take $14.25 and multiply by the number of people. All right, that's it. Go ahead and try a few on your own, and I will see you soon.